Charging by friction. Let's talk about insulators and conductors. This should mostly be a review from chemistry. For an insulator, it's a poor conductor of electric current. I know we're not there yet, but let's think about the fact that electric current is moving charges, and you have some experience with that from class. Whereas a conductor has relatively low resistance to the flow of electric current. It allows all those free electrons to move. In an insulator, the atomic electrons are bound to the atom within the material. There are still some free electrons, so you can rub your object, maybe, and get some of them to escape, but for the most part, they're bound to the atom and don't really move around. In a conductor, you can think of the free electrons as able to flow within the material like a fluid. Some examples of insulators are rubber, plastic, glass, silk, all the things we played with in class. There are also materials called semiconductors, which have added impurities to allow for conduction, but if they don't have those added, then they're an insulator. So things like silicon. Most metals are conductors, and most things that aren't metal are not conductors. But that's not hard and fast. So things like copper, aluminum, and gold are all extremely good conductors of electric current. So why does rubbing something charge it? Okay, another flashback to chemistry. Do you remember learning about atomic energy levels in an atom? They maybe look something like this. These are the energy levels of a hydrogen atom, where you have the ground state for the electrons, and you could excite the electrons and they had higher energy. So if an electron gained enough energy, the atom could be ionized. You might have seen this level as the ionization energy of an atom. So where did that electron actually go? Well, it became free to cause a net charge somewhere else. And where did that electron get the energy? Well, friction does work, and work transfers energy. Are all materials the same at giving charges away or picking them up? As you saw in the activity in class, no, they're definitely not. So scientists, before we actually had all the sort of tools to look at the microscopic properties of materials, came up with the triboelectric series. And they essentially did what you did in class today. So they were able to sort on a scale, all right, the list of objects of the property of these things to either tend to lose electrons and become positive, or the tendency to gain electrons and become negative. So human hands, when they're really dry, I don't know if you've noticed in the winter, but your hands will actually give off electrons. Now, Teflon, as you saw in class, picked up electrons like nothing else. And that's because it's made with a lot of fluorine, which is extremely electronegative. You can make the connection back to chemistry using those properties that you learned about, like electronegativity, and applying that to the macroscopic object that you're looking at here. You don't need to know this scale, but it is interesting to think about the fact that not all materials behave the same way electrostatically.